Hello everyone. In this video we're going to calculate molecular formulas, and we're even going to do those from empirical formulas. So molecular formula, if you remember, is how something actually appears in nature. It's true formula. Again, these are mostly applicable to, they're applicable to ionic substances, but especially molecular substances, okay? So it says mesotylene has an empirical formula of C3H4. And then the experiment to determine molar weight of this substance is 121 AMU. I'm going to change that to grams per mole for our purposes because it's a little bit easier for us to understand. We don't really deal too much with atomic mass units. What is the molecular substance? What's the formula of that molecular substance? So if I have an empirical formula of C3H4, as the problem mentions, but I needed a molecular formula, okay? So that's my question mark. That's my X. What do I do? Well, I have a little bit of information here. It says that I have 121 grams per mole of this real substance, okay? So that's the molar mass of this stuff here, but I can figure out the molar mass of this stuff here, which is actually, 36, but that's 40, okay? So 12 times 3 plus 4 is 40, so that's 36 plus 4 is 40. Now I notice if I analyze this, I see that this is 3 times bigger than 40. 121 is 3 times bigger than 40. So since there's a 3x factor, and there's 3 times the mass of this stuff versus this stuff, then there should be 3 times the particles of this. So it's not C3H4, it's C9H12. Done. Okay? So I just tripled this. 3 times 3 is 9, 4 times 3 is 12. Okay? That was it. So if I move on to a problem that has antifreeze, which is composed of these percentages, we've already seen problems like this. So let's jump in here and just convert these directly to, or just make them grams, not convert. And then 9.7 grams of hydrogen and 51.6 grams of oxygen. And we want to convert these to moles, okay, because moles is fair. It's a counting unit, and things combine on a mole-to-mole basis, not a mass-to-mass basis. 16 grams of O and 1 mole of O. So this all cancels. Okay, so what we have here is we need to divide out 38.7 by 12. We end up with 3.23 moles of carbon. We end up with 9.7, same number, divided by 1, still same thing, moles of hydrogen. And this is actually 3.23 moles of oxygen. So my empirical formula, which is what letter A is asking us for, what is the empirical formula, is C, by the way, I forgot, divide by the lowest. And 3.23 is the lowest. It's actually represented twice. So we end up with 1 mole of carbon, 3 moles of hydrogen, and 1 mole of oxygen, okay? Roughly 3, in other words, hydrogen. So it's CH3O. That's my empirical formula. Well, it says that this stuff has a real molecular formula. The real molecular formula could be the empirical formula, but in this case, I don't think it is. So let's see if we can calculate, let's see if it's different. So it says it's 62.1 grams per mole, okay? With 62.1 grams per mole is the mass of the real substance. Well, this is my empirical formula. The molecular formula, again, is what I'm trying to solve for. That's 62.1 grams per mole, okay? This stuff is 31 grams per mole, okay, when I add up a carbon, 3 hydrogens, and an oxygen. Well, that happens to be double. So if this has double the mass, this must have double the particles of C2H6O2. And that's our molecular formula, okay? Let me know if you have any questions.